Hello. Today we're going to study trigonometric functions, starting chapter 6. But before we can deal with trigonometric functions, we're going to have to talk a little bit about their basis in angles. When we talk about angles, we need to start with the Cartesian plane, the xy axis. Every angle has an initial side, which starts at the positive x-axis, and a terminal side that is anywhere else on the Cartesian plane, right? What this will do is it will rotate or go across, and that will be the angle, the distance these two things are apart, these two rays are apart. Typically we use Greek letters like theta, alpha, gamma, zeta, or sometimes even t. We use them to describe our angles, right? When we move in a counterclockwise direction, we call that a positive angular movement, right? When we go counterclockwise this way. A clockwise direction, we consider a negative angle. That would be moving in that direction. When we talk about angles, the terminal side, right, we have our initial side at the positive x-axis. The terminal side can land really in any one of these four quadrants, right? And we label them as 1, 2, 3, 4, right? Kind of the order in which we would hit them if we moved in a positive counterclockwise rotation, right? Sometimes we might have an axis land right on the positive y-axis, negative y-axis, or so on and so forth, right? Those we'll cover in a little bit later. But how do we measure these angles? And what we need is something called degrees or radians, right? And a positive angle formed by one complete rotation, we said, will be measured in degrees, and there will be 360 degrees. Radians will be a complete positive angle formed, and one complete rotation is what we're going to call 2 pi radians. And so our intuition is set in degrees. And so what we want to do is try and convert to radians. Radians are really used in arithmetic, right? We can use them a lot better in arithmetic operations. So we might have our intuition based in degrees, but we'll want to work mathematically in terms of radians. So how do we convert? Here's how we convert if we're starting in radians and want to go to degrees, right? If this is how we want to build our intuition. We're going to take our angle and multiply it by this factor of 180 over pi to go from radians to degrees. But if we have our degrees and we want to actually work with it mathematically, we're going to need to change it to radians. So we're going to actually want to multiply our degrees by pi over 180. So for example, if I want to know how many degrees 3 pi over 4 radians is, I have my 3 pi over 4. And because I want to go from radians to degrees, I'll multiply that by that 180 over pi factor. Right? When I do that, let's see, these pi's will cancel. I can take a 2 out of this, and again another 2, 45, and I multiply, and I get 135 degrees. Right? So that helps build an intuition. On the other hand, I might be given degrees and want to know how many radians it is, right? I might actually want to work with 25 degrees mathematically, so I need to change it to radians. So I'm starting with degrees and going to radians, so pi over 180 is my factor. So I take 25 and multiply it by pi over 180. Let's see, I can take a 5 out of 25 and a 5 out of 180. And my final answer will be 5 pi over 36 radians, right? So then I'll be able to work mathematically with this angle, which is actually equivalent, just written in different units. The last thing we want to look at are these common angles. We're going to want to know what their degrees are, right? We list the common degrees out here. We're going to want to know what their radian measures are and where the position on the Cartesian plane is. Right? So 0 degrees will actually correspond to 0 radians, and it will be the positive x-axis. Right? That's where the terminal side will lie. 30 degrees will have a radian measure of pi over 6, and it will have a terminal position. Its terminal angle side will be in the first quadrant. 45 degrees will have a radian measure of pi over 4, and it again will be in the first quadrant. 60 degrees will have a pi over 3 radian measure. Again, it will be in the first quadrant. 90 degrees is going to have a radian measure of pi over 2, and its terminal side will actually be the positive y-axis. Right? And then 180 degrees will have an angle measure of pi, and it will be the negative x-axis. That's where its terminal side will lie. 270 degrees has a radian measure of 3 pi over 2, and its terminal side position will be the negative x-axis. And 360 degrees, one full rotation, is equivalent to 2 pi radians, right? That's one full rotation. And again, its terminal side will be the positive x-axis. Right? This is just a beginning study of what we're going to do with trigonometric functions. Next, we're going to talk about how these fall into the unit circles, but this will be another lecture in class.